All right, on the left is 50 milliliters of vinegar at 70 degrees Celsius, and on the right is 50 milliliters of vinegar at 2 degrees Celsius. It's been chilled in water. So gentlemen, can you take the thermometers out and lay them inside the plastic container, not inside the beakers, but inside the, there you go, like Caesar, there you go. All right, now, inside the big glass beakers is exactly 30 grams of baking soda. So there's 50 milliliters and 50 milliliters, and then 30 and 30. So this is the same size stuff. The only difference is the temperature. At the same time, I want you guys to pick up the containers and dump the vinegar into the beakers. You're gonna dump your vinegar into the beaker on the left, Caesar, and Jason, you're gonna dump your vinegar into the beaker on the right. So get your beakers, or get your graduated cylinders, and in 3, 2, 1, all of it now. Caesar's reaction is already done. Jason's reaction is still going on. So what did you notice about the speed of the reaction and the difference? Jason, go ahead.
The cold one went faster, and lasted longer.
The cold one lasted longer, which means that it took longer to go all the way through. Yeah. And the hot one? It
went slower. So like.
It went slower, or it was done quicker?
It was done quicker. Yeah.
It was done quicker, which means that when the baking soda and the vinegar reacted, it made carbon dioxide super quick and then was done. Whereas on the cold side, it made carbon dioxide really slowly and slowly bubbled up to the top.
Yeah.
All right. Later on, I want you guys to watch this video. Once I post it to YouTube, I'm going to attach a link to the Edmodo page so that you can see it and you can watch in slow motion the reaction between the hot and the cold vinegar. All right. All right, so on the left, I have a beaker of ice water that is at 2 degrees Celsius. And on the right, I have a beaker of hot water that is 75 degrees Celsius. And then I have 2 identical glow sticks. Now you both know how to use glow sticks, right? You bend them, you snap them, and then you shake them till they light up. I want you to go ahead and snap them. Shake. All right, so they are both identical. Hold them don't put them in yet, but hold them over. So they are both identical. They're both lighting up with about the same amount of light. On the count of 3, you're gonna put yours in the cold water, Danielle, and Bashoy, you're gonna put yours in the hot water. So 3, 2, 1, go. All right, now, it takes a little bit for the solution inside to chill out and to heat up, because right now, the stuff inside, the chemical reaction that's occurring inside the glow stick is room temperature, but as we speak, the cold one is cooling off and the hot one is heating up. What do you notice is going on as far as the amount of light that's being output? James?
There's steam coming out from the right one.
Well, the right one is the hot one. The steam's rising because it's hot, but look at the glow sticks. What do you notice is happening to the amount of light in the glow stick?
Oh, because the light is heating up the water.
The light is not heating up the water. Glow sticks don't give off heat.
This one is dumber.
All right, Danielle says the one in the cold water is dimmer than the one in the hot water. Is there anybody that disagrees with what Danielle just said? So you can see that the reaction in the cold water is slowing down. The chemicals inside the glow stick are not reacting with each other as quickly, whereas the chemicals in the hot one are doing what?
The opposite. They're going
They're doing the opposite. They are reacting very quickly. Now let me ask this question. Think back to the baking soda and vinegar that we just watched. When you dump hot vinegar into the baking soda, the reaction ran quickly, but it also ended. The hot water. The hot water ended faster. So the glow stick on the right, the glow stick on the right is burning brighter right now, but it is going to burn out in less time than this glow stick in the cold water. Whenever you guys were kids and you were playing with glow sticks, did you ever have an adult tell you to put the glow stick in the freezer if you want it to last longer?
Yeah.
Okay, some of you did. This is what they were talking about. The downside to that is that the reaction isn't as bright. The upside to that is that the cold water reaction will actually run for several hours. If you put it in the freezer, it might even run for several days, but you don't get to enjoy it because it's in the freezer. If you leave it out at room temperature, it doesn't burn quite as bright as this one on the right, because this one on the right is in a very hot environment right now, but it will burn out usually it's overnight. When I was a kid and my parents would give me a glow stick, I would snap it and play with it that night, and then I'd take it to bed, and when I'd wake up the next morning, it would be very dim if it was even working at all. Did you guys have similar experiences?
Yes.
So the chemicals seem to have worked all of their energy out, and they're no longer reacting with each other. All right? Okay. Thank you both. Okay. So on the left, I have a beaker of ice water that is at 2 degrees Celsius. And on the right, I have a beaker of hot water that is at 81 degrees Celsius. Inside the smaller beakers, I have 2 chunks of 37 grams of dry ice. Now, you guys have done the dry ice experiment before. You know that when you dump dry ice into water, you get fog, right?
No. Yeah.
You're about to see it if you've never seen it. My question to you is, can you predict what's going to happen based upon the other two, the baking soda and vinegar and the glow sticks? Can you predict what's going to happen or what you're about to see? Who's got it? All right, Will.
Either one of the glasses, the hot or the cold one, will have the reaction longer.
Which do you think is going to have the longer but slower reaction?
The colder.
And which one's going to have the faster and more violent reaction? Does anybody in here disagree with Will?
I think my good.
All right, everybody agrees with them. All right, Lissy and Stefan, do not touch the dry ice. You're going to pick up the beaker and you're going to pour into the container whenever you're ready.
Don't miss it.
Try to be careful not to splash. Okay. So on the right, you can see the hot water is making a heck of a lot more fog than the other one.
Can I touch the fog?
So Will was correct. This reaction is going to proceed a lot slower, and you're going to have fog for a lot longer period of time. And on this side, the hot water is going to produce a lot more fog in a short amount of time.